Hi, I'm Trevor with ClearEdge 3D. Join me for this webinar where we'll be taking a look at the GEXCEL HERON, one of the most exciting SLAM solutions. We'll be taking a look at everything from control points to doing live change detection on the tablet. So it should be a really awesome webinar with a lot of cool content, and I'm really excited to have everyone there. I'm joined with Matteo from GEXCEL. So can you tell us a little bit about the new HERON system?
So as you can see here, the new system comes with the new camera, high-resolution camera, 8K single-shot images and 4K streaming video. Everything is controlled by this light control box, which can be attached also on mobile device like, I don't know, a robot or a trolley. Everything is powered with an internal battery for 1 hour and a half of acquisition. Then you can additionally add this extra battery to control the device. We can also see something in real time.
So everything's actually self-contained right here
Exactly.
on this. Tell us a little bit about like the storage capacity. What's the storage on this?
Here you can acquire around 250 giga of data.
So about 200 gig or 250 gigs of data.
Exactly.
So
One peculiar thing of this system is that nothing remains inside the box. So also for the safety of your clients, if someone wants then to, let's say, remove the data from the control box, everything is stored inside here on a USB dongle.
look at that.
Yes.
So for security purposes right here, we have all our data. So nothing's in the cloud, nothing like that. All that's
Exactly.
local for especially those kind of real high security applications. Again, so full data security right here. So in addition to having, I guess, the self-contained unit, we can also still put the unit inside the old form factor right here. So we have the full self-contained Pelican case that has basically everything right there. So you get the best of both worlds. You can either roll with the rugged option right here, or if you're trying to travel light, again, everything's also self-contained right here. So
Exactly.
excellent form factor on that one.
There's a special belt to carry these also in a very light way.
Yep.
This is how the PDA application looks like. So here we can insert a project name like Denver. We can choose an acquisition name, and now the system is start to capturing. When we want to capture an image from the high resolution camera, now here we can acquire control point like visual target, pole tag, so you can mount the head on a monopod, and you can measure control point on the ground.
Again, that's super important, especially one of the big things with all the SLAM technology out there is like drift. So being able to quickly acquire like control points to help constrain the trajectory and really ensure like the best possible accuracy. So that's something I'm really excited to see. One of the new features of the HERON is this control point workflow, again, to get the best kind of survey, kind of more of a survey almost workflow, again, acquiring targets as well as those points on the ground to help constrain everything. So
here we can also see how a high resolution picture is
got our
acquired.
down.
Exactly.
See this.
Now it's downloading. Once you are downloading, you can start to walk again.
Yep, and so this is also taking a little bit of break. I want to also highlight the older HERON. We had the full tablet where you could actually see anything. Is that? So that's that 8K imagery right there. So we have all of us, our wonderful videographer. Look at that. And I am absolutely impressed. That is actually some really cool image quality right there. And so that's the high resolution static capture. But again, just to reiterate, while you're doing this, it's also taking taking continuous imagery, so you have the continuous imagery that you can almost play like a moving bubble view. So if your image capture is something important to you, you have both options, correct?
Exactly.
Excellent.
The continuous capturing is also used to colorize the point cloud. So in order to arrive to a RGB point cloud at the end of the process.
Yeah. So you have your point cloud full colorized and everything.
Yes, exactly.
That's fantastic.
And as you've seen, there's no initialization steps. You can start to acquire right away.
Just turn the unit on,
Exactly.
you're ready to go. So nothing, no calibration, nothing like that. So you can either do, it looks like we have the head dismounted right here. We can have the head either handheld, or we have the backpack mount right here. We could use it like a traditional over the head, walking around and capturing. And it sounds like you also have the options either with the your little handheld device, or we can use a full tablet so we can actually see the data capture on the screen, correct?
Yes. The tablet is mainly used to visualize the real-time trajectory, so it's possible also to see what you're capturing in the field. And also a peculiar tool that HERON offers is the possibility to make change detection. So if you have acquired the data the day before and then you come back in the same place here, you can measure the differences between day 1 and day 2. And this is called tracking mode. It's the possibility to localize yourself with respect to a previous acquired acquisition, or even with a BIM model that you can have of the environment you are going to scan.
And that's something, again, in today's day and age, especially where I think construction QA, QC, especially with some of the ClearEdge portfolio with like Verity and everything, this whole, ensuring things are being built correctly and being able to scan regularly, basically have useful point cloud data, we can see construction mistakes. That's something you can do that right there on the tablet with the Heron out there, walking around and doing on-site verification.
Yeah. And when you are on the field, you can take notes of where you see the major changes. And then when you're back in the office, I can show you also something here on the
Actually, if you wouldn't mind,
text.
I would love to see if you could pull that up real quick. Let's take a quick little tour, and let's actually take a look at some of this change detection we have.
So here, let me show something. So this is an acquisition that we did yesterday, and we compare with the second acquisition acquired today. And you can easily see painted in red the moving people, for example, or the different stuff that has been located in the place before day 1 and day 2. So this is the capture we did yesterday. So you can see the green line is the trajectory where we walk through, and synchronized with the trajectory, we have the continuous acquisition from the 4K images. So you can see your picture while you're moving. And here we can also see, let me load these and load the final cloud. We can see the final model of this area acquired yesterday during the construction phase of G-Week. So you can see
This is the point cloud
exactly
right there.
And we can also display automatically. We can create a 2D map
You
of
have your
these
2D ortho photos, so we have that there at the bottom. And it looks like we have our trajectories there. So this is actually something I personally really like about the Heron is the ability to combine multiple data sources. So I'm not just limited to doing everything in one capture. I can break up larger projects, and then back in the software, I can actually combine that. And I can also introduce things like static scans. Static is kind of help kind of align everything. But you can see right here, we have our multiple captures loaded in. At the bottom, we have our 2D ortho photo right here. The little blue dots, that represents our static capture from the Heron. And then we have our image data at the top here. And are we looking at the...
Here, it's where we are located at that moment.
Right, so this is basically, and there we go. You can see where we are right here.
This is the booth where we are located now, acquired yesterday. And then we can measure the changes between the yesterday situation and what we can capture now.
Excellent. That is absolutely one of the coolest, I think, features is, again, quickly being able to go out in the field and basically show that change detection right there on the tablet. Again, for very quick decisions about, hey, what's being built correctly versus what's being, installed incorrect, not correct. That's something I'm actually really excited to see with this system.
This is another example of, let's say, of industrial plants where you can navigate along all these pipe and complicated stuff. And in correspondence of each of these dots, you have also the high resolution picture that can be overlapped to the point cloud. So here we have the colorized information, so the high resolution image where you can really see the details of all these pump, valves.
That is fantastic. So if you're trying to pick out information or for asset tagging purposes, you have that high resolution photo that you can fall back on in addition to the point cloud. So you're almost getting like the best of both. So here we have an example. This is the point cloud collected from the Heron. We've got a larger oil and gas facility right here. So I guess you want to take us through, Matteo, and kind of tell us a little bit about this.
As you can see, this is the final point cloud produced by the system. It's around 20 minutes of walking around this complicated area. Again, the advantage of having this mobile system is really that you can cover a large area in short time and describe a lot of, you see, geometrical details. And as I showed you before, you can also overlap imagery information that allows you to see.
And one of the unique things, especially about reconstructors, you can also import geometry, like your IFCs, correct?
Exactly. So this is, let's say, the end environment where we bring all our data acquired with HERON is Reconstructor, where we can combine different sensors.
So you could also bring in your tripod-based data if you had any drone data. So you can really all bring it in here, and you have one kind of central software package that allows you to work with all that data, filter it, register it. And I think that is something, again, especially as we have more sensors out there on the field and different companies, different data collection methods, you really can bring it all in here and kind of get everything lined up together.
Right.
Yeah, so we got the advantage where we can combine all our different data sources together in one kind of big ecosystem. We got a point cloud that combines SLAM, aerial data, as well as the tripod-based scanning solutions.
Yes, let's say, we used to say that there's no one instrument that can cover all the needs in the field, so we offer a platform that allows to combine static scan, drone data, of course our HERON data, total station data, and also CAD model in the same.
And you can do everything from point cloud filtering, editing, georeferencing. You can do all that in here, correct?
Cross sections, orthophotos creation. As you can see here, we are able to produce out of this 3D point cloud, this orthographic view. Now it's opening.
And that's like the standard, that's like a 2D X-ray ortho photo, so we can get quick floor plans. And then we can actually take those and we can actually bring that in. So we can do dimensions off of this, as well as I believe you can also drop this into CAD, correct, Matteo?
Yes, this from here you can export directly into AutoCAD. Has a raster image scaled, and if in the meantime you have also created some vector, like, I don't know, distances, here you can zoom and see how long is this pipe, the diameter of this other pipe, so you can measure what you want, insert your annotation, and bring everything into CAD environment.
And one of the big questions is every one of these SLAM solutions, you're doing fast data collection, but how long are we looking at for processing? Like, would you say it's like 1-to-3 ratio? What would you say on average for
more or less what we say that, let's say, if we do, I don't know, half an hour in the field, let's say with data transfer and everything, you have around 1 hour back in the office.
and all that processing is local,
Exactly.
so there's no concerns about data. And again, I'm guessing the more powerful computer you have, the faster that processing.
Exactly, and then what is appreciated is that everything is processed locally. You don't have to share your data with anyone, so you can have the entire control of what you are.
Again, for data security purposes,
Sure.
No, that definitely is I think that's something I appreciate about being able to control of my data. That's something I love about this ecosystem.
I mean, Heron is used also for nuclear security, so it's
Nuclear
something.
And actually, that brings us to the next point. You mind telling us a little bit about kind of more of the common applications of kind of how the Heron's being used?
As I mentioned, let's say originally Heron has been created for controlling for nuclear security and for decommissioning action. When they dismount a nuclear plant, they have to track the changes during the dismounting action. So this is why we have this strong capability of make change detection in real time and also in post-processing. Then the system is very versatile. It can arrive with 2 sensors and a camera, with 1 sensor and a camera, or only 1 sensor, depending on the environment where you want. You see here there are the different models, and these different models can be applied in different application field. I mean, here you see construction area, but it can also be used in mining sector, in industrial application. Here is again in underground cavity, new construction building. This is the real-time acquisition where the user can see what is capturing in the field. This is the capability of measuring control point, but you can even put your system in a manhole to capturing cavities. We are very strong in underground mines, thanks also to all these additional tools like a long pole that allows you to reach difficult areas, like in this case.
Right, that's a pretty rugged system right there. And again, because the whole backpack, you are strapped into that, so you can climb ladders, you can go up, down hills. Like that's something. Again, you don't have to worry. That system is going to be rugged enough to basically go wherever you need it.
Exactly, and it can be, let's say, configured in different position and heads in order to enter also in narrow passages like underground mines, open pit mine, where of course you have constraints from the external environment.
Yeah. And again, basically, being a laser scanning system, you don't need to have an external light source. I mean, sure, it's nice to have for the imagery, but you can go into like a pitch black mine or scanning at night, and you'll be totally fine for all your imagery.
In case you need also the color information and the light is not sufficient, as you have seen in one of these pictures, you have also the possibility to add an extra light to create more.
So you can actually add an onboard light source.
Yes.
And that's one of, again, the things with the Heron. It's configurable enough so you can have everything from the camera system, the light source that you can add on to that, to the sensor configuration. That's something you can all customize depending on your use application for the Heron, correct?
Yeah, this is the, let's say, the versatile configuration is one of the, let's say, main appreciated quality of our system.
No, that is absolutely fantastic. And in this current setup, you mind telling us a little bit about like the range as well as points per second, or any highlights that you would like to talk about?
These, in particular, this sensor mounts 2 LiDAR, one with around 250 meter of range, horizontal, and 32 lines, and another oblique sensor with 100 meter of range, 16 lines. The camera is 8K. You can capture this environment that we have seen here in around 15 minutes.
As fast as you can walk it, basically.
Exactly.
And again, since we got that oblique sensor, we're capturing the overhead as well as we're getting great horizontal coverage. So we're getting basically full field of view around.
Yeah. The combination of the 2 sensors is exactly to cover also the roof area, or when you go under tunnel to cover
And that comes back to the SLAM algorithm itself, so that we have plenty of good data, so that way the SLAM algorithm can do its thing and basically align and ensure our best possible accuracy, since we do have that great coverage.
Another important thing, our desktop application allows to minimize the typical drift that a SLAM approach can have with what we call global optimization. So at the end of the process, we're able to combine the different viewpoints of the systems in order to minimize the possible drift from these viewpoints.
And that really ensures like the best possible global accuracy at the end of that collection.
Exactly.
No, that's absolutely perfect. Thank you, Matteo, so much. And I believe next step is we'll go ahead and do a quick cut here, and then we'll actually be using the system and take a little spin on it.
I'm joined with Giogria, Worldwide Sales Manager for GEXCEL. Continuing on with our little look at the HERON system, we're now going to take a look at setting up the instrument and actually doing some scanning. So, Giogria, mind telling us a little bit about the instrument setup and kind of getting it all ready?
Yeah, thanks, Trevor. Okay, now we are going to see how we can set up HERON. Okay, so as you see, everything is stored here in this backpack. The backpack is very nice. I love it because you can use it as transport case and also as an operative case.
So everything's self-contained in that backpack.
Exactly.
And I'm guessing that absolutely can fit on like your carry-on luggage, or if you're riding the train or something, you can easily transport it.
Exactly. You don't have to ship and waste your time. I mean, waiting for your luggage. Everything is stored here. So you have the controller here, the battery, the space for extra battery.
Spare battery.
The capture head is stored here, different kind of cables for charging and everything. The pole that we will use later on in order to mount the capture head.
Yep. I'll go ahead and hold that for you.
Okay. And here is stored the PDA, the personal digital assistant that we use to control the device, to switch on and to acquire all the data. So how to set it up? That's very easy. May I give you also this?
Go ahead and be your helper for today.
Thank you very much. So let me do like this. Okay. We can just remove our capture head from here and always remind to remove also the protection.
Always got to make sure you got the lens cap removed.
Exactly. Then we have already switched on the battery here. Okay. And the cables are already connecting here. The USB to store the data is already inside the controller. So what we have to do now is to also take the other cables, because we do have to connect the capture head to the backpack. Okay, so now we can close.
Go ahead and close that up. Here, I can get the other side for you.
Thank you very much. Okay, so now we can mount the pole.
Let's make sure, let's see.
Yeah,
this the right
mountage
way?
of the pole is very easy because you have a little red dot. Okay,
Fixed
the capture head.
Get the capture head aligned right there.
Yeah.
Press down the button, slide it in, and there we go. We're all mounted up.
Now we have only to connect the cables. Okay, so also here it's easy to mount. Red with the red here.
Just line that up and slide in. That's super simple.
Okay, and also the connectors here are very robust. So there's...
so that maintains, again, that rugged form factor, so you don't have to worry about interference from dust or stuff like that. Again, it maintains the whole kind of environmental protection of the whole system.
Exactly, and you also avoid to detach the cables, okay? When everything is well connected, there's a little light, blue light here.
I don't know if you can hear everyone. You can actually hear the systems all fired up. We got the little hum of our sensors going.
Okay, and here we are. Now we are ready to scan.
Yeah.
It's very also...
So I can go ahead and hold this.
Thank you very much.
Make it a little easier having a helper.
As we have already mentioned before, we don't do... Okay, that's fine.
Yep.
Good. We don't have to make any kind of calibration or initialization procedures, so just a few seconds for the warming up, and we are ready to work. By the personal digital assistant, we have the application here to start, okay? So we can just press select a folder that we already have, or even create a new one, and we can set Denver demo, okay? Now we can select which kind of modality of acquisition we want for the camera, if the continuous streaming or the single shot, and now we are ready to work. So everything is clear. If we press start, we can start scanning. We don't need to stop somewhere, so we can continue to acquire our data continuously. Of course, we don't have any kind of limitation in terms of passing through different kind of environment. So we can easily walk through the doors.
This whole time it's basically capturing image data as well as your point cloud, and it's doing all of that for you.
Everything is here. And of course, we even don't have any kind of limitation in moving up to the stairs. We can make a little part over there. And the other important thing that we have already mentioned before is that we don't have to close the loop when we make our acquisition. So we are totally free to start in one place and then end the acquisition in another place. While scanning, we can stop and acquire the single shot, or even we can add annotation during the scanning. And this is something that is pretty useful when you are scanning an environment and you would like, for example, to add annotation like fire plant or I don't know. You want just to save some annotation during your acquisition so that later on in the post-process you have all this information already recorded. When you want to stop, and here we are.
Perfect.
Everything is done.
Everything's done, and we can just break down the system, take the USB out, and then we can bring it over, and we're ready to go.
Exactly.
So, do you mind telling us a little about the live change detection, Giorgia?
Yeah, so the goal of the change detection is comparing models acquired in different time in order to underline some differences. Of course, this change detection can be run also using as a reference model, a BEAM model that can be uploaded in the system. So basically, how does it work? After uploading the reference model in the HERON can localize itself, so it can track its own position, just comparing the common geometry. And then, if you want to display the differences between the survey at time 1 and time 2, or the differences between the BEAM model and what you are scanning, you just localize yourself in the position, and then when you start walking, you can easily display the differences in 3 colors. So the green basically are the...
So the green is like the common overlap between the last
the
scan.
surface without any kind of differences. And then you can display in yellow and in red the area with differences. Of course, here everything is red. That means the ceiling, because in the previous reference model, we did not have the ceiling. And so
we can see what's new, and that's something we can actually export out later, and we can get a color-coded point cloud showing the differences, right?
Yeah, exactly.
So we can actually see, even as people are walking around right there, you can see them actually being color-coded as red. And that's something that's really cool, that live right there out on the field, we can actually see those changes. So you can see right there as people are moving. Again, we're at Geo Week here in Denver. You can actually see as people are coming in and out of the conference. Since those weren't in the original reference map, they're actually being color-coded as a difference. So again, really powerful functionality. I love that, where I can do a quick on-site verification showing my differences, and then we can actually take this data and do a further analysis back in the office. That is something that's absolutely a really cool, fantastic workflow, I think.
Exactly, correct. Because the data is not only visualized, but it is stored also on the system. And so you can use it to create further analysis or histogram or any kind of report you might need to complete your change detection analysis.
Perfect. And again, that is probably one of the coolest things, like right there. Again, that live change detection right there on the tablet. That is an absolutely awesome feature, I think. Well done. Hands off to you guys at GEXCEL. I think that is definitely one of the coolest pieces of tech here. So
Thank you very much.
Today we'll be going over some of the cool things we can do with SLAM data. The emergence of SLAM has really brought about almost a renaissance in data capture, where I can capture more data than ever before. But that really leads us to a question of what can we do with this data? And one of the cool things that we're pleased to announce at ClearEdge 3D is currently we actually have a beta of using SLAM data for construction verification. So if you'll come on and join me, we'll actually go ahead and take a look. So the advantage of this workflow is I can quickly go through and actually do my SLAM scanning, bring that into the Verity and use it for progress tracking for construction. Again, for progress tracking, we don't necessarily need the exact measurements of an element. We can go through and more checking the installation status if something is there or not there. And that is perfect for kind of the SLAM devices in today's market. So the overall advantage is I can, again, quickly go through, scan, and then afterwards I can verify my elements and check and see how much has been installed. So one of the things we're really proud to announce at ClearEdge 3D is we currently have a beta for Verity, allowing for construction verification on our SLAM data sets. One of the key notes, though, as far as the workflow goes, is that SLAM data does tend to be a little bit noisier than traditional tripod-based laser scanners. That being said, we can still use that SLAM data, and that provides a very fast method for installation statuses and progress tracking. In that case, we don't necessarily need exact dimensions. Again, more caring about whether an object is found in the point cloud, meaning it's also been constructed inside the field. So let's go ahead inside of Verity and take a little bit of a look at some of our elements. So here on the left, we can see it looks like all our walls have been built. And again, we can verify using our color codes. Green means we're in tolerance, and it looks like we have a couple little out of tolerance walls over on the left. Again, this is more of an example piece, so I've already actually gone through and kind of tweaked a little thing just so we could get some different results. So over here on the right, let's go ahead and take a little bit of a look. And again, the primary use for this data is for construction progress tracking. So I can see some of my fits, and that's looking pretty good over there on the right. Again, with the overall turnaround, I can quickly scan out in the field. Again, one of the unique things with the GEXCEL HERON is I can go through and live see on the tablet my change detection, and then I can go ahead and take that SLAM data into Verity, run against my model inside of Navisworks for more complete progress tracking inside of the software.
Thank you everyone so much for joining us for today's webinar. I hope it was a really cool webinar with a lot of functionality. Again, feel free to email us. We're always more than happy to answer any questions. And with that, enjoy the rest of the day and happy modeling.